In this video, we're going to look at an improper integral that actually involves a few of our integration techniques and limit techniques. So, as with any improper integral, first step is always to turn it into a limit. So, we first are going to rewrite this as the limit. I like using a when it's the lower limit, but it's completely up to you. Just don't use x. Anything else is fine. Limit as a goes to negative infinity of x, the integral from a to 0 of x e to the x dx. Now it's a proper integral with a limit out front. So we're going to kind of forget about this for a second. And how would we do this antiderivative? This is an integration by parts. And it's going to be an integration by parts with u equal to x and dv equal e to the x dx. So all of our integration techniques are still in play with improper integrals. V is very easy, as the antiderivative of e to the x is just d to the x. And du is actually very easy because the derivative of x is 1 dx. So putting this back together, we do need to keep writing limit, otherwise it's not equal. We'll just keep that out front. Some people might use some quotes like that, and that's fine. But putting back together our integral, we have x e to the x. I'm going to wait until the very end to incorporate my limits. I'm going to find my antiderivative first, minus the antiderivative of v du e to the x dx from a to 0 and a to 0. We could incorporate the limits now and then do this antiderivative, or we'll just do them in the same step. So limit as a goes to negative infinity. Let's do this part first. So these are my big parentheses that correspond to that. Now here I'm going to have 0 times e to the 0 minus a times e to the a. Alright, so that's upper limit, lower limit. So that is that part there. Here, minus, always keep track of that minus. Always need good bookkeeping when you're doing integration by parts. The antiderivative is e to the x from a to 0. So we're done taking antiderivatives, but we do have to put this thing back together and see and then take our limit. Limit as a goes to negative infinity. This part here, obviously 0 times e to the 0 is just 0. So we have negative a e to the a minus e to the 0 minus e to the a. Okay, let's see what all we can figure out. E to the 0 is 1, not 0, so be careful in there. So we have limit as a goes to negative infinity of negative a e to the a minus 1 plus e to the a, distributing this negative over those parentheses, equals. This part depends on a, and this part depends on a. So those are going to be limits that we need to look at. So I'm going to write this out separately, and then we'll see how we can calculate each of those. So limit as a goes to negative infinity of negative a e to the a minus 1, that doesn't depend on a, plus limit as a goes to negative infinity of e to the a. Now if we think of the graph of e to the x, just draw a quick little sketch up here. It's our exponentially increasing graph. Now we're doing it as we go to negative infinity, so e to the x goes to 0. So this piece here is just equal to 0. This is going to be equal to minus 1. Here is the piece we need to figure out. Putting in negative infinity, we already know e to the a is 0. We know that this is infinity. This is an infinity times 0 case. That means we need to check that out with LHopitals rule. It's an improper form. So let's do a little bit of scratch work on that, and then we'll come back we're just going to look at right now the limit as a goes to negative infinity. I'm just going to pull the negative out front of a e to the a. Probably the easiest is to write it as a over e to the negative a. This is to negative infinity. Now we have a negative infinity over infinity case. So this is an infinity over infinity. It qualifies for L'Hopital's rule. And that means I'm going to be retaking a limit as a goes to negative infinity of 1 over negative e to the negative a. These negatives will go ahead and cancel, and we get the limit as a goes to negative infinity. I'm going to go ahead and move that back up to the top, e to the a, which equals 0. So it turns out this limit also equals 0. So when all said and done, we get that our improper integral is equal to -1.